Hi, my friends. Today is Friday, October 25th, 2024. I'm Mike Knoll, and today I want to talk about error prevention. This is also called error proofing or Poka-Yoke or Poka-Yoke in Japanese. I prefer just saying error prevention in English. I want to explain what it is, why it's important, and once you see this, you're going to want to implement this into your problem solving. What is it? It's a system or a physical restraint built into a process to detect, prevent, or eliminate errors. A good example is if you have a 110 volt appliance plug, it won't fit into a 220 volt outlet and vice versa. That's going to prevent you from, say, blowing up your 110 volt American hairdryer when you're on vacation in Italy where the voltage is 220. Error prevention is also an integral part of Lean and the Toyota production system, but it also just makes good sense to use it. In my previous video about human error and root cause analysis, I used the example of parts that can be installed backwards. And error prevention here, you could just redesign that to fit one way. That would be prevention. So in error proofing, there's three levels. There's detection, which is the most basic one, prevention, which is better than detection, and elimination, which is better than prevention. So going with that hairdryer in Italy example, detection, let's say you plug your American hairdryer into the Italian outlet and the fuse blows. The error actually happened. It was plugged into the wrong voltage, but the signal the fuse blowing happened before any damage could occur, and that's detection. So prevention, which is better than detection, is what I mentioned before. The plug just won't fit. And you could rewire the plug to make it fit, but then that's on you. And when your hair dryer blows up, you had to defeat the plug, didn't you? And then there's elimination, which is better than prevention. And I've traveled a little bit, so I know hair dryers you have to plug into the right voltage, but phone chargers, laptop chargers will adapt to 220 or 110, and that's elimination. So there's no chance you can plug it in, you can use an adapter, you could rewire it, it's going to work just fine. Another way to explain this, to make sure that we're not just talking about plugs, is use the analogy of a train crossing. So in that example, detection would be your plain old train crossing with a railroad track going over a road with a sign. And if you drive up, the driver has to see a train or hear a train horn to know there's a train coming and not drive onto a track. Prevention would be a crossing that has the gate that comes down. And you could still drive around that barrier it would be a little difficulty, but that's going to prevent you from driving over the road. Elimination is the best solution. So if the train track were, say, elevated above the road, then there's no way a driver could drive over that train track at all, let alone when a train's coming. And elimination in this example is often the most expensive solution, but that's not always the case. So it's worth it to keep looking at those preventions. Sometimes that's the easiest way to go. So why is this important? So right on the face of it, if you can prevent equipment from being damaged or non-conforming product from being shipped to a customer, that's worth something right there. But also, it is the responsibility of the organizational management to set workers up for success. The worker is there doing his job the best way he knows how, to follow these processes that are given to him to achieve the goals of the organization. It is the organizational management, not the workers, that determine the organization's mission, vision, and goals. They set up the procedures to achieve those goals and provide the workers with tools, unless you're a shop where you have to bring your own tools, equipment, facility, and other resources to carry out those procedures. if the resources and procedures don't set the workers up for success, then it's not fair to blame the worker. So in my experience, as an example, we had an issue where a software disk was accidentally erased. And we did a formal root cause analysis and preventive action process. And when we were thinking and coming up with corrective actions, I asked the engineers if there was some way we could Poka-Yoke this thing. And they looked at me as if I'd used some obscure Japanese word they'd never heard before, which is actually what I did. And then I just said, okay, well, that's a fancy way of saying error prevention or error proofing. And then they still looked at me like they didn't know what I was talking about. So I said, okay, I think we have an opportunity here. The next time we meet, I'll give you a little Poka-Yoke training. And then I went back and talked to my quality colleagues, and I got some information off the internet, and I put together a little PowerPoint presentation that took about 15 minutes. And when I was done, they said, well, that's just plain old common sense. We can fix that. And it didn't take them long. They wrote up a snippet of code that completely prevented the disk from being accidentally erased. And my favorite part of this was that I was able to take that solution to the other sections that were doing the same thing, and this became the standard for the site. So my message is this: when you're doing problem solving, keep error prevention in mind. It is a powerful tool, even though it looks like plain old common sense. Thank you very much for watching my video up to this point. You can find me on YouTube as @QualityMike84. I'm on Facebook as BPMW, and I'm on LinkedIn. If you find me on LinkedIn, I have a book an appointment button there. You can schedule a call, a video conference, or a face-to-face meeting if you're in the northeast suburbs of Dallas, Texas. We've also got a small networking group going. We met in Wiley last week, and we did a resume workshop, and we talked about the importance of elevator pitches. So get in touch with me if you want to get attached to that. Thank you very much. Goodbye.